What might you say if I told you that there is a frozen system floating through the universe, serving as a living fossil for billions of years? The James Webb Telescope has now found such a living world fossil. This universe has not shaped new stars for billions of years, yet it still exists. What is this galactic marvel truly about? The fossil universe is a world that essentially consists of older stars and has not formed any new stars for billions of years. In astronomy, fossil galaxies are considered remnants from the beginning of the universe, providing researchers with fascinating insights into the formative history of galaxies and the developments of the early universe. Typically, such intriguing fossil galaxies are found at the center of massive galaxy clusters, where they may have been left over from merging galaxy groups. However, these curious universes raise questions. Why did some galaxies freeze and essentially stop developing so early after their formation? And why are these universes still active in their own way? These galaxies have barely changed their shape and composition since the dawn of the universe, making them witnesses to an era we still know very little about. The James Webb Project should finally give us valuable insights into the earliest history of the universe. Since the launch of the telescope, we have been astonished repeatedly. The telescope is revealing scientific wonders by the dozen, and the list of cosmic mysteries is getting longer and longer. We still don't fully understand why and how galaxies formed, and we know next to nothing about why galaxies have been clustering together more and more as the universe has evolved. Research is currently focusing on extremely old and distant galaxies that date back to the beginning of the universe to finally see the true evolution of matter. The fossil universe that the James Webb Telescope has now discovered is another rare case on the list of discoveries. This galaxy formed incredibly early and evolved in ways that would typically take billions of years for other galaxies. This galaxy took only a fraction of that time. This burst of star formation is what astronomers call a starburst. In a short period, the galaxy produced billions of stars, forming a perfect elliptical spiral shape. Then, star development in the galaxy essentially froze, and since then, this galaxy has barely changed. It's considered a scientific wonder how these beautiful galaxies can continue to exist despite the stagnation in star formation. It's probably due to the distribution of gases and the influence of dark matter and dark energy that a galaxy becomes a fossil so early in the evolution of the universe, a rarity, indeed. However, the effects of dark matter and dark energy on the evolution of visible matter and galaxies are still poorly understood, making it difficult for scientists to make conclusive statements about the true nature and dynamics within fossil galaxies. The world fossil NGC 1277 in the Perseus galaxy cluster is incredible. With instruments like the James Webb Space Telescope, we're now able to examine objects millions or even billions of light-years away. Thanks to its exceptional infrared spectrometers, the James Webb Telescope can capture light in frequencies hidden from the human eye. Webb collects the faintest traces of light and converts them into images that we can see. This technology allows scientists to see through clouds of cosmic dust for the first time. Cosmic dust is a common phenomenon, and ultimately, all matter and galaxies in the universe are made up of dust and gases. The dust in space can be so dense that telescopes like Hubble often fail due to impenetrable walls of dust, obscuring whatever lies behind them. Infrared light can penetrate dust clouds, enabling Webb to turn these light trails into images. This is how we now see areas of the universe that were hidden from Hubble's eyes. Hubble was already an achievement in space exploration and managed to discover NGC 1277, which is around 220 million light-years from Earth, despite its limitations. This galaxy is another living fossil from the early epochs of the universe. The stars in NGC 1277 are extremely old. Imagine a galaxy in which there are almost only ancient stars, a composition of beauty, form, and function that has undergone no significant development for billions of years. The majority of stars in this galaxy are around 10 to 12 billion years old, and these stars are far from reaching the end of their lives. In comparison, our Sun probably has a total lifetime of only around 9 billion years. It's strange that this galaxy has produced millions of incredibly long-lived stars. Researchers would love to understand the processes that led galaxies to develop into beautiful, star-filled structures in double-quick time. They would also like to know if all galaxies in the young universe developed in this way. The starburst hypothesis is currently the most popular explanation for the surprisingly old and evolved galaxies Webb has found. Explosive developments could be why, 200 or 300 million years after the Big Bang, thousands of beautiful and highly evolved galaxies were already present in the universe. In contrast to fossil galaxies, regular galaxies have evolved since the beginning of the universe. Stars were born, stars died, and galaxies merged with others, changing their appearance and shape over time. NGC 1277, on the other hand, has not formed any new stars for billions of years. The galaxy consists almost exclusively of ancient, metal-poor stars that were typical of the early universe. Until now, however, scientists believed that these old stars of the first populations didn't have particularly long lifespans. In NGC 1277, these early light and metal-poor stars are evidently quite stable and reach an almost unbelievable age. Some previously unknown factor could have frozen the processes within the galaxy. Understanding exactly what this factor is would be of utmost importance. A force that first propels entire galaxies into development and then freezes them, allowing them to continue in their once gained form, could reveal a previously unknown magnitude in the universe. Interestingly, NGC 1277 contains a very large black hole at its center, which makes up around 14% of the galaxy's total mass, an unusually high mass proportion. There are also various peculiarities around this black hole. Normally, this black hole would need to consume a significant portion of the galaxy's matter over billions of years, causing the galaxy to contract, especially if it doesn't form new stars. So far, it's not known whether the mechanisms of the black hole in this galaxy have somehow halted its growth. NGC 1277 is also not located at the center of a large galaxy cluster, unlike other fossil galaxies. This galaxy is relatively isolated in a region of the universe where there are few galaxies. The James Webb Telescope has also found a galaxy with an Einstein ring. Have you heard of an Einstein ring? These galactic objects were long a theoretical assumption. It was mainly the mathematical genius Albert Einstein who predicted the existence of these objects, though no one had seen one for nearly 100 years. Einstein rings are essentially unique cases of gravitational lensing. However, they don't form a magnifying glass-like curve but an almost perfect ring. The James Webb Telescope has now discovered a galaxy that actually has one of these objects, known as SDSS J1226+2149. It's another of those rare cases in science, and once again, we have the incredible capabilities of the new telescope to thank for the discovery. Only James Webb's fine sensors were able to capture the faint emissions from this marvel in the depths of space. The Einstein ring around SDSS J1226+2149 was created by the distortion of light emitted by the galaxy. An intervening galaxy cluster has stretched and distorted the light through mass in such a way that it stretched into a ring shape. In this case, the stretching is not only an interesting physical effect but also causes significant magnification of objects behind it. Thus, an Einstein ring has a similar effect to a gravitational lens. Both effects allow researchers to see objects that are extremely far away and nearly invisible to our eyes. Without these effects, the very first Einstein ring ever seen was in the galaxy cluster Abell 370. This cluster even offers one of the most spectacular examples of a complete Einstein ring ever observed. This effect allowed astronomers to examine the distant galaxy in detail and gather information about its structure and the rate of star formation within the galaxy. Beyond this fantastic aspect, the Einstein ring around Abell 370 is another perfect example of how the general theory of relativity works in practice, continuing to enable new astronomical discoveries. Thanks to the gravitational lensing effect, astronomers have been able to see many other objects in the universe. The galaxy GN-Z11 is one such object, one of the oldest and most distant galaxies ever discovered. It has gone down in the annals of science as an example of what can be revealed by modern space telescopes like Webb. History books of stargazing place it around 13.4 billion light-years away, dating back to a period roughly 400 million years after the Big Bang. With the assistance of the lensing effect, the light from this galaxy was enhanced, allowing astronomers to gain significant insights into its design and structure. Thanks to gravitational lensing, even the Hubble Space Telescope made this discovery when scientists thought the telescope had long since reached the limits of its power. Max J 1149 plus 2223 lens star 1, the most distant individual star ever seen, was also found through gravitational lensing. The star is located in a galaxy around 9 billion light-years away. Without the gravitational lensing effect caused by a cluster of galaxies between the star and Earth, the light from this star would be too faint to detect. The gravitational lensing amplified the light by over 2,000 times, enabling astronomers to study a single star at such an immense distance in detail for the first time. Individual stars from afar are a rare treat for researchers. Now, with the help of the James Webb Space Telescope, we can break down light signals, like those from Max J 1149 plus 2223 lens star 1, into their components. This capability allows scientists to conduct precise analyses of the elements and gases that formed the stars of the early universe. Thank you for watching this video. I hope you enjoyed this journey into the mysteries of the universe. If you found this video interesting, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel for more amazing updates.